Your objective for lesson 13 is I will find areas of rectangles. So today we're going to be working with more than one rectangle and finding the area of both of them. Okay, so you have a grid template in your binder. It's just a grid. It doesn't have anything shaded on it. Um, don't start right in the middle of your grid. Start at the top somewhere because on your grid there's going to be quite a few things that you're going to have to shade in today that we're working on in the concept development. So on your grid paper, just start at the top so you have more room to work whenever we're working through the concept development. So if you need to push pause and get that ready, you can. Okay, so on your paper, I want you to go ahead and draw and shade this shape right here on your grid template. So you're going to have 4 unit squares up at the top and you're going to have 8 on the bottom of it. Push pause, and when you're ready to move on, you can push play. So how can we find the area of this rectangle, which there's actually more than one rectangle? Can you find it by just multiplying the side lengths of the rectangle? Because when you look right here, this has a side length of 4, this has a side length of 2, 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 and this has a side length of 4. So you cannot multiply the side lengths to help you find the area on these rectangles. So when you're looking at this shape just as a whole, it's not exactly a rectangle. If I were to draw a line, probably right here, or even right here, I could break it up into 2 different shapes and that would help me find the area. So the only way to find the area of this shape is just by counting the unit squares inside. We wouldn't be able to multiply the side lengths to find the area of this shape. So on your piece of paper, I want you to draw a line right where I have this dotted line to break apart this shape into 2 different shapes so we can find the area of both of the shapes. So go ahead and draw your line right there where I drew mine, so where you're breaking it apart into 4 unit squares and 8 unit squares. And then we're going to write an equation that tells the area of the square on the top. So what equation can we use to find the area of this square right here on the top? I want you to go ahead and write that equation on your board. Whenever you're ready to check it, you can push play. So we can use 2 times 2 equals 4 to find the area of this square because there is a side length of 2 right here and a side length of 2 right here. Now we need to write an equation that tells the area of this rectangle on the bottom. So go ahead and write that equation on your board. Whenever you're ready to check it, you may push play. Okay, we would have used 2 times 4 equals 8 because this side length has 2 and this side length has 4, and all together there are 8 square units. So how do we use those 2 measurements, which is the 4 and the 8, to find the area of this entire shaded figure? So go ahead and write your last equation on your board to find the area of this entire shaded figure. Whenever you're ready to check that, you may push play. Okay, so we would have used 4 plus 8 equals 12. So the area of this rectangle and this square all together are 12 square units. So underneath this shape on your grid paper, I want you to go ahead and write 12 square units. And inside of this right here, this square, if you want, go ahead and put a 4 because we knew that this area was 4. And inside this rectangle right here, I want you to put an 8. So that way we knew what the area of those were. And then I'm going to go ahead and put on my page, just like you're writing on your paper, what the area of that shaded figure was. So this is kind of what it's going to look like on your grid template whenever you're writing it. If you need to push pause before we move on, you can do that. Okay, so the same shape, we can also find the area of the shaded figure by thinking about a 4 times 4 square with a missing unit. So you can see right here how I drew a square around the whole thing, and now that I have this, I have 4 right here, and I have 4 right here, so I could go ahead and do 4 times 4 to find the area of this entire shape, but that's not going to tell me the area of the shaded shape. So if I did 4 times 4, that would give me 16. But that's telling me the area of all of this right here. And the only part that I need to know is this shaded part. So when I look over here at this white space, I see that there are 1, 2, 3, 4 square units. So if I take 16 and I minus 4 from that, it's going to leave me with 12. And that's going to tell me what the area of this shaded figure is. So there's two different ways that you could do what we just did. You could draw the line right here like we did, or you could just draw a box around the entire figure and find the area of the entire thing that you boxed in, and then subtract the white part that's not shaded, and that's going to leave you with the area. So whatever is best for you to do, I want you to do it that way. So now we're going to go ahead and we're going to draw this shape on your board, or not, I'm sorry, not on your board, but on your grid template. Okay, and I want you to notice that I have on the screen both ways that you could do it. So I'm going to go ahead and I'm going to let you choose the way that you would rather do it. If you're going to choose to do it this way, where you draw a line right here, then do that, but make sure that in this part of the shape you're writing the area, and for this part of the shape that you're writing the area, and then underneath it, I would like to see what the total area is. If you're choosing to do this, make sure you find the area of the entire figure, and then you've got to subtract the white part, so you are left with only the shaded part. So I'm going to let you try this one on your own. Make sure you have all of this right here shaded in on your template, and then choose one of these strategies to find the area of the shaded shape. Whenever you're ready to check your answer, you may push play. Okay, so the area is 14 square units. If you did this one, I'm going to go ahead and show you what I expected you to put. I would have expected you to put 4 right here, and I would have expected you to put 10 right here. And I was expecting 14 square units to be written at the bottom of that. For this one, I was expecting you to have put 20 minus 6 equals 14 to show me what step you took, and then for you to put 14 square units as well. So if you need to correct anything on your paper, please go ahead and do that before we move on. The reason I want you doing this is just so I know what steps you're taking to help you find the area. So when you're ready to move on, you can push play. Okay, now we're moving on to a new shape. You don't have to draw 2 of them. Remember, you only have to draw 1. I just want you choosing one of these strategies. So I want you to go ahead and shade in the shape that you see right here on the screen on your template, and whenever you're ready to move on, you may push play. So you have this shaded in, so go ahead and choose which way you would rather solve this problem, if you'd rather draw the line right here, or if you would rather just box in the entire area and subtract the white area to help you find the area of the shaded figure. You can do that, but I want you to notice on this one that there is white right here and there is white right here, so there are 2 different places that you're going to have to count the unit squares to take away from the entire area to help you find what the area of this shaded figure is. And remember, whenever you're working on one of these on your paper, I'm going to want to see the area written on this shaded part and this shaded part, and I'm going to want to see the total area down at the bottom. For this one, I'm going to want to see the equation you used to help you find the area, and I'm also going to want to see the total area written underneath it. So you choose which method is best for you. And whenever you're ready to check your answer, you may push play. Okay, so the area was 16 square units. Over here, I was expecting you to put 10 because this rectangle was 10, and right here, I was expecting you to put 6 because this rectangle is 6. I was expecting you to put 16 square units underneath the figure that you drew. Right here, I was expecting you to put, there is 5, 25 minus 9 is equal to 16. And then the area of the shaded figure was 16 square units. So if you need to fix anything on your paper before we move on, make sure you're doing that. Okay, now we have a new shape that you need to shade. This is probably the last one that we're going to be shading on our template because the next few problems that we're going to use we won't need the grid template for. So go ahead and get this shaded on your template, and whenever you're ready to move on, I would like for you to push play. Okay, this one, there's a line drawn completely across right here. So if you're looking, there is actually one shape right here, one shape right here, and one shape right here. So that's 3 different rectangles that you're having to look at to find the area of the entire shaded figure. For this one right here, you just got this white section that you would have to subtract from the total area of this boxed in rectangle. By now you should know the steps to take and what you need to write on your paper as you're doing this. So whenever you're ready to check your answer, you can push play. Okay, so the area of the shaded shape was 24 square units. If you chose to use this strategy, I was expecting it to look like this, 12, 12, or 12, 6, and 6. And when you add all of those together, you get an area of 24 square units. This whole rectangle was 30 units, and when you take away the 6 from the white area, you were left with 24, so the area of the shaded figure is 24 square units. Okay, so this figure shows a small rectangle that's cut out of a larger rectangle, which the larger rectangle would be the whole thing right here, and this white part was cut out of it. So we're going to figure out how to find the area of just the shaded figure. Okay, so the way that we do this is we just imagine that this white shape wasn't here. We're just imagining that this whole thing was shaded. And so since we know that this side length is 6 centimeters and this side length is 6 centimeters, we could figure out the area of this entire shape right here. So on your board, I want you to go ahead and figure out what is the area of this entire square if this whole thing was shaded in and we didn't see this 4 centimeters by 2 centimeters. So on your board, go ahead and write the equation that we would need to find the area of this entire square, and go ahead and write down what is the area of this entire square. Whenever you're ready to check your answer, you can push play. Okay, so the equation was 6 times 6 equals 36, so the area of that square is 36 square centimeters. So now all we have to do to figure out what is the area of the shaded figure is just take away the white part of this square. So we know that this side was 2 centimeters and we know that this side is 4 centimeters. So on your board, write down the area of this white rectangle. Okay, so I know that the area of the white rectangle is 8 square centimeters because I know that 2 times 4 is going to give me 8. So if this right here is 8 square centimeters, then what can I do with 36 square centimeters and 8 square centimeters to figure out the area of just the shaded part of this square? Okay, all we have to do is take 36, subtract 8, and whatever that is equal to, that's going to give me the area of this shaded shape. So on your board, I would like for you to figure out the area of this shaded shape. And I would like for you to write the area on your board. Make sure you're not just writing the number, that you're using your square centimeters with your answer. When you're ready to check your answer, you may push play. Okay, so I know that 36 minus 8 is going to leave me with 28. So the area of the shaded shape is 28 square centimeters. So it's kind of like what we were doing earlier, where we boxed in the whole shape and then we took out the white part. This is the exact same thing. It's just this time you don't see all of the square units. You just see the side links and you're just multiplying. Okay, so now we have another one. Here is the big rectangle that is shaded, and we're going to have to take away this white part to just figure out what the shaded part is. So we're going to imagine once again that this white rectangle is not there and that this was all shaded in. So on your board, I want you to find the area of this entire rectangle. Whenever you're ready to check your answer, you can push play. So the area of the entire rectangle would have been 24 square inches, because 4 times 6 gives me 24. So now I need to take away this white rectangle, and that would leave me what is shaded. So I want you to figure out what is the area of the white rectangle, and I want you to take that away from 24, and that's going to leave us with the area of the shaded part. And make sure you're writing down the area of the shaded part of this rectangle on your board. When you're ready to check your answer, you may push play. Okay, so I know that this rectangle right here was 6 square inches, because I know that 2 times 3 is 6. So when I take 24 minus 6, it gives me 18. So the area of the shaded part of this rectangle is 18 square inches. Okay, moving on to a different type of problem now. This figure shows the same thing. We still have a large rectangle, but we're having to take out this white part of the rectangle just to figure out what the shaded part is. But we have some things missing right here and right here. So we're going to have to figure out what are these side lengths to be able to know how large this rectangle is. Okay, so looking at what we already know that this whole side length right here is 11 feet, and we know that this whole side length right here of the rectangle is 9 feet. We know that this area right here is 4 feet, and we know that this area is 5 feet. So if you remember, we talked about this a few lessons back. On rectangles, opposite sides are equal. So that's telling me right here that if we know that this right here is 11 feet, then this side of the rectangle also must be 11 feet. If this side right here is 9 feet, then that tells me that this side right here must also be 9 feet. So we're going to ask ourselves, what can we add to 5 to give us 11? Because we're wanting this whole side to be 11 feet. And for over here, we're going to ask ourselves, what can we add to 4 to make 9? Because this whole side of this rectangle needs to be 9 feet. So on your board, let's do this side first. I want you to write down what number can you add to 5 to make 11, because we're going to need to put that right there, so that way this side of the rectangle is 11 feet. So go ahead and write the number that we can add to 5 to make 11 on your board, and push play whenever you're ready to check it. Okay, so you should have put 6 feet, because when you add 6 and 5 together, that is going to give you 11 feet. So for this white part of the rectangle, we know that this side length is 6 feet. Now on your board, I want you to write the number that you can add to 4. That's going to give us 9, because this side length needs to be 9 feet long. Push play when you're ready to check your answer. Okay, so we put 5 feet, because when you add 4 and 5 together, that gives you 9. So now we know that this side length of the rectangle is 6 feet, and we know that this side length of the rectangle is 5 feet. So now that we have these two side lengths, can we figure out the area of this white rectangle? Yes, you can, because we know that we have a side length of 5 and a side length of 6, and all we have to do is multiply those together to find the area of this rectangle. So on your board, I want you to find the area of this white rectangle, and I would like for you to write that. Whenever you're ready to check your answer, you push play. Okay, so the area was 30 square feet because I know that 5 times 6 is 30. Okay, so if we know the white rectangle, all we have to do is take this white rectangle away from the entire rectangle, but first we have to figure out what is the area of this entire rectangle. Okay, well, if I know that this side length is 11, and I know that this side length is 9, all I need to do is multiply 11 and 9 to give me the area of the entire rectangle. So on your board, I want you to go ahead and do that and find the area of this entire rectangle so we can take 30 away from that to help us figure out what is the area of the shaded part. So find the area of this entire rectangle and write that on your board. When you're ready to check your answer, I want you to push play. So when you take 11 times 9, you get 99 square feet. So this entire rectangle is 99 square feet. And now all I have to do to figure out what the shaded part of the rectangle is take 30 away from 99, and that will give me the area of the shaded part. So I want you to go ahead and do that on your board and write down the area of what the shaded part of the rectangle is. And make sure you're pushing play when you have that answer. Okay, so when you take 99 minus 30, you are left with 69. So the area of the shaded part of this rectangle is 69 square feet. Okay, so it took us a few more steps for this problem because we had to find the missing side lengths, but it's just like what we've been working on. Once you have found those missing side lengths, you take the same steps that we did on the last few problems. Okay, so we're going to go ahead and we're going to get our problem set. If you need to push pause to get that ready, you can go ahead and do that. Okay, so for number 1, it says each of the following figures is made up of 2 rectangles. So you're going to have to find the total area of each figure. So for these, you can go ahead and do it the way they have it, where they've got the lines drawn here, or you can box in the entire shape and find the area of the entire shape and then take out the white part like we practiced in the concept development. I'm going to let you choose what works best for you. But down at the bottom, you will have to work out the problem for A and B and C and D and E and F and G and H. So it's not going to be down at the bottom where you have to subtract the white part. Down here at the bottom, you are just adding what A and B are together and what C and D are together and what E and F are together and what G and H are together. So it may be best for you just to find the area of both shapes and then add them together when we're doing this front part of the problem set. I want you to notice on G that they don't have a line drawn anywhere. So you're going to make the choice of where you should draw the line on this figure to break apart the rectangles. So they already have 18 there for you because the area of A was 18, so you didn't have to do that. All you have to do is find the area of B and add that with 18 down here to find the area of what A and B are together. I'm going to go ahead and let you work on this front page of the problem set yourself because we did a lot of this in the concept development and I feel that you're ready to do this on your own. When you're ready to check your answers, you can push play. Okay, so for rectangle B, the area was 9, and when you added those together, you got an area of 27 square units for A and B. The area of rectangle C was 18, and the area of rectangle D was 15. And when you add those together, you get an area of 32 square units for both A and D. Okay, when you looked at E and F, the area of E was 9 and the area of F was 21. So when you add 9 and 21 together, you get 30 square units. I have two different numbers here for G and H because you could have drawn your line two different ways. If I were to take this out, you could have drawn a line right here. And if you drew a line right there to break up the rectangles, then you would have had 35 plus 20, and that would have equaled 55. If you were to take this line away and you just drew a line right here, then the area of G would have been 49 and the area of H would have been 6, and altogether it was still 55 square units. So there's two different ways you could have done G and H. Both ways would have been correct though. Okay, we're going to move on to the back side of the problem set. This figure shows a small rectangle cut out of a bigger rectangle. You need to find the area of the shaded figure. So we're going to have to work to find the area of the big rectangle, which is this whole thing. And then you're going to have to find the area of the white rectangle. So that's why I put this right here on the paper, because I do want you to go ahead and write this on yours as well. I want you to put the big rectangle equals, and I want you to put the white rectangle equals. And then we're going to write down the area of both of those to help us solve this equation up here. So go ahead and get this written on your paper and push play when you're ready to move on. Okay, so we know for the big rectangle that we're looking at 10 centimeters and 9 centimeters, and that's going to help us find the area. So I want you to go ahead and multiply those together, and right here next to the big rectangle, I want you to write down the area of that and push play when you're ready to check your answer. Okay, so the area of the big rectangle was 90 square centimeters. You did not have to put 10 times 9, but I did expect you to put 90 square centimeters. Now I want you to put down the area of the white rectangle and push play when you're ready to check your answer. Okay, so the area of the white rectangle was 12 square centimeters because all you had to do was 4 times 3. So up here on this blank, it says the area of the shaded figure is what, and then you have to take away the white part, and that's going to leave you with the area for the shaded part. So right here, we know the blanks for this, and you just have to find the answer for this. So I want you to go ahead and take the big rectangle and subtract the white rectangle from that, and that will leave you with the area for the shaded part of this rectangle. So go ahead and fill in these blanks and push play when you're ready to check your answer. So we know that the large rectangle was 90, and when we take away the white rectangle, we're taking away 12. And when we do 90 minus 12, that leaves us with 78 square centimeters. So the area of this shaded part of this rectangle is 78 square centimeters. Okay, we're going to move on to the bottom part. This figure shows a small rectangle cut out of a big rectangle. So the big rectangle is all of this right here. And they're taking out this white part so we can figure out the area of this shaded part. So once again, we have some side links that are missing. Okay, so they give us this whole side length right here, which is 9 centimeters, and they give us this one up here, which is 4 centimeters. So to figure out this side length, you're going to have to ask yourself, what are you going to add to 4 that would give you 9, because that will tell us what this side length is right here. So I want you to go ahead and write down what this side length is and push play when you're ready to check that answer. Okay, so this side length is 5 centimeters because when you add 4 and 5 together, that will give you 9. So now we need to find this side length because we already know that this side is just 3 centimeters, but the whole length of this side should be 7 centimeters. So you're asking yourself, what can you add to 3? That would give you 7, and that's what's going to go right here. So whenever you're ready to check that answer, you can push play. Okay, so this side length is going to be 4 centimeters because we know that 4 plus 3 gives us 7, and this whole side length needed to be 7 centimeters. So now we know what we can use to help us find the area of this white rectangle, since we have a side length of 5 and a side length of 4. So we have done part A, but now we need to work on the rest of these parts. The part B says that we have to find the area of the big rectangle, so this whole big rectangle. We know that this side length is 7 centimeters, and we know that this side length is 9 centimeters. So we're going to put that in these blanks on our paper, because we multiply those together to get the area of the large rectangle. On your paper, I want you to go ahead and write down what is the area of this large rectangle, and push play when you're ready to check that. Okay, so the area of the large rectangle is 63 square centimeters. And now we have to find the area of the small rectangle. So we need to multiply 2 side lengths, and then we're going to get the area for the small rectangle. So I'm going to go ahead and let you do this part on your own for this white small rectangle, and push play when you're ready to check your answer. Okay, so for here you should have done 5 times 4. If you put 4 times 5, it's fine, they're still the same. But the answer would have been 20 square centimeters. So now that we know that the large rectangle is 63 square centimeters and the small white rectangle is 20 square centimeters, you know what to do with these two numbers to help you figure out the area of just this shaded part of the rectangle. So you're going to work that problem out down here on this bottom line to help you find the area of the shaded part of this rectangle. Whenever you're ready to check your answer, you may push play. Okay, so you should have had 63 minus 20 equals 43 square centimeters. Okay, you need to go ahead and take out your exit slip. Once you have this finished, you can bring it to me.